Chapter 3, Electrochemistry 3.2, Nernst Equation. By the end of this lecture, students should be able to write the Nernst equation for a given galvanic cell, explain the factors that affect cell potential, use Nernst equation to determine cell potential, concentration or partial pressure of a species, and equilibrium constant when E cell equals to 0. Predict the spontaneity of a cell reaction. What is Nernst equation? For most electrochemical cell reactions, they are done under non-standard conditions. Therefore, the Nernst equation is used to relate the cell potential under non-standard conditions, E cell, to the cell potential under standard conditions, E naught cell. From this equation, convert the ln expression to log. Next, substitute R, T, and F. The Nernst equation that we are going to use is E cell equals to E naught cell minus 0.0592 divided by N log Q, where Q is the reaction quotient and N is the number of moles of electrons. Pairing two electrochemical cells done with different concentrations. On the left is what we call standard conditions, so its cell potential is noted as E naught cell. Whereas on the right is what we call as non-standard conditions, so its cell potential is noted as E cell. Why use Nernst equation? There are three uses of Nernst equation. It is to determine cell potential or EMF, to determine the concentration or partial pressure of a species, and to determine the equilibrium constant K when E cell equals to 0. The following is an example of when Nernst equation is used. To get the overall cell reaction, students need to convert the given cell notation by writing down oxidation reaction at anode and reduction reaction at cathode. Next, students also required to calculate the E naught cell by referring to the table of standard reduction potentials. Next, students are required to calculate the concentrations of copper 2+ ions, noted here as X. Students are also provided with the value of cell potential and the concentrations of silver ions. This is where Nernst equation is used. From the overall cell reaction obtained earlier, the reaction quotient Q is concentration copper 2+ divided by concentration of Ag+ square. Remember, only aqueous and gas phases included in your reaction quotient Q. Refer to Chapter 6, Chemical Equilibrium SK015. By substituting all the values in the Nernst equation, X is obtained. Next, to explain the effect of increasing concentration of copper 2+, students need to refer to the Nernst equation again. Increase in copper 2+ concentration will cause the value of E cell to decrease. This is due to the E0 cell having to subtract a larger value. Next, to explain the effect of adding sodium chloride crystals to the silver half cell, students need to know that sodium chloride releases Na+ ions and Cl- ions into the silver half cell. The Cl- ions from NaCl causes the concentration of Ag+ ions to decrease because they react to form AgCl salt. Referring to the Nernst equation, a decrease in Ag+ concentrations causes the value of E cell to also decrease. To relate the cell potential to the equilibrium constant K, we need to substitute into our Nernst equation the two conditions of equilibrium. First, no net reaction occur, therefore Q is equals to K. Second, the value of E cell is exactly 0. By substituting these two conditions into the Nernst equation, we obtain E0 cell equals to 0.0592 divided by N log K. The following shows an example of where students need to relate cell potential value to equilibrium constant K. Remember, equilibrium constant K has no unit. Predict the spontaneity of a cell reaction. When E cell is larger than 0, the cell reaction is spontaneous. When E cell is smaller than 0, the cell reaction is non-spontaneous. And when E cell is equals to 0, the cell reaction is at equilibrium. The following shows an example of when to determine the spontaneity of a cell reaction. First, calculate the value of E0 cell. Next, using the Nernst equation, calculate the value of E cell and determine whether the E cell is larger, smaller, or equals to 0. Predict the cell reaction spontaneity. End of Chapter 3, 3.2 Nernst Equation.